So bath escapes are capable of submerging to great depths in the ocean. What is the gauge pressure at a depth of 6 kilometers, assuming that seawater has a constant specific weight of 10.1 kilonewtons per cubic meter? Express your answers in pascals and psi. I grabbed a picture of a bath escape here, and I'm only assuming that I'm saying that correctly. I could be wrong on that. I've used this as a test question before, so it really gets everything that I want to get out in there. So let's just begin. So once again, we'll draw a quick little free body diagram. There's the surface of the water. There's our bath escape. It's down at 6 kilometers. Remember that up from the surface is 0. Our point 1 will be the surface of the ocean. Our point 2 is where the bath escape is going to be. And so let's take a look at what we know. Well, we know that Z2 is going to be, it's down negative 6 kilometers. We know that our specific weight is 10.1 kilonewtons per cubic meter. And we also know it says gauge pressure. And since it's gauge pressure, that means that we're ignoring atmospheric pressure, and so P1 will be 0. And at 6 kilometers down, gauge pressure is fine because we're going to find that it's a very high pressure, and so that 14.7 psi or so that the atmospheric pressure adds isn't really going to affect it much. Okay, so let's write the hydrostatic equation. P2 minus P1 is equal to negative gamma Z2 minus Z1. We already know that P1 is 0, so that's going to fall out. Start plugging in our numbers. So negative 10.1 kilonewtons per cubic meter. So remember that kilonewtons, that's 10.1 times 10 to the third newtons per meter. We're going to multiply it by Z2, negative 6 kilometers, minus 0 kilometers at the surface, and we want to put that into meters. So we're going to need to cancel out that kilometers. So 1,000 meters on the top is 1 kilometer. So that way the kilometers will cancel out and leave us meters. And one of those meters will cancel one of those meters out, so we'll be left with kilonewtons per meter squared. So we're going to find that the pressure at point 2, if we multiply all those numbers out, is 60.6 times 10 to the 6th Newton meter squared. Or what we can say is that is times 10 to the 6th, so that would be 60.6 gigapascals. Now, we do want to convert this answer also into our English system. So what I'm going to do is I'll just put it right down here. I'm going to take that number. I'm going to look up the conversion factor, which is 1.45 times 10 to the negative 4th. And that's psi per Pascal. So if I multiply those two together, I get 8,790 psi. And so you can see why I said that the atmospheric pressure really doesn't matter, because 8790 as opposed to 8804, not really a lot of difference.